Okay, so welcome back. So I'm going to explain in this video how to solve this problem, reaction rate through linearization. So the problem says, it is found that the rate of a reaction may be correlated by this equation. Reaction rate equals A times P to the power 1 over C times T to the power B, where P is the pressure, T the temperature, and A, B, and C are empirical constants. Instructions are linearize the above equation, place your answer in the box to the right. Use the data provided to calculate the appropriate values so that you can create three plots whose slope will give you A, B, and C. Show each plot. Okay, so let's start with here with the equation. What we want to do is use properties of logs. We know the properties of log is the log of a product, A, B, and C equals the sum of the logs. So we can break down this into three logs. Take logs on both sides. ln of C equals ln of A plus ln of the second term, P to the 1 over C, plus ln of the third term. Now we're going to use the second property of logs. Log of A to the B equals B to the B times log of A. So by doing so, we got the final equation. ln of C equals ln of A plus 1 over C, ln of B, plus B, ln of T. Now, because we're changing both temperature and pressure, here we have our table. Our initial values are these three columns. What we can do is we can calculate ln of P and ln of T. And we're going to run two series of experiments, one in which we keep pressure constant, and then we can make this graph of ln of C versus ln of T. So that's what we did here. So at a pressure of 6.1 bars, which is these three first rows, we're going to make this graph of ln of T versus ln of C, plot on Excel, and then get the linear regression and the equation from here. Just to show you here, when I select the data, this is the series. So I'm taking the X values are ln of T for the first three rows, and the Y value is the ln of C. Okay, from Excel, we can get the equation, which is here. Now we can write down the equation. So Y equals 2.3486x minus the Y-intercept. But what is important here is the slope equals B, which is the first constant we're looking for. So B is 2.3486 for this problem. You can write that here. Okay, that was running the experiment at constant pressure. Now what we can do is run now the experiment at a constant temperature. If we do so, we take now these three rows at a temperature of 330 Kelvin. And now we're going to make a second graph of ln of C versus ln of P at T constant. We're doing this graph, right? At T constant. Again, do the graph. Let's see, select data. Now I'm using these three rows. So this is the X value, ln of P, and the Y value is ln of C. Okay, so do the graph. And from Excel, you get the equation. This is the new equation. Y equals 0.7734x plus 9.1173. So when we compare this with the equation, we see the slope 0.734 equals 1 over C. From there, we can find what is the value of C. So we have now the value of C, 1.2930, which we can put here. Now, to solve for the last empirical constant, which is A, what we are going to do is take the whole equation and say, let's call this Y, and this whole thing to be X. And we can do that because we already know what is B and C. So we make this column, which we take P to the power 1 over C times T to the power B. We know these constants. And now we're going to make our last graph, which is here. Our last graph is going to be reaction rate C versus this. Make the graph in Excel, and now the equation here, this is the equation coming from Excel, is going to be this one, and the slope here is what we are looking for. This is the slope, is A is 0.0119. Okay? And we write here, these are the answers. Okay, let's look at the explanation. Since the equation has more than two independent variables, so in this case, we have two variables which are pressure and temperature, we need to run a series of experiments in which we first keep one constant while changing the other one. linearizing equation using the rules of logs, yields linear equations that can easily solve for B and C utilizing the slopes of the separate slopes of separate equations. So the first equation gives me the slope gives B, and the second equation gives 1/c is the slope, find C. Once they have been approximated with regression, the original equation may be linearized by taking A as the slope and the entire expression to be X. So that's the entire expression now is X, again here from the initial. This is the entire, this is X and this is Y. Making this plot, we obtain the value of A, which I have here in my last graph here. Okay, so this is my example. You can follow this to complete your assignment. The numbers are not the same as what you have in your assignment, but you can follow this video and then use the numbers in your problem to get the correct answer. Okay, have a good day. Thank you.